Hello, science and space enthusiasts. Are you ready to embark on a journey into the depths of science and space? Today's topic will be how the sun, our largest source of energy in the universe, produces energy. The sun plays a vital role not only for life on Earth, but also for the entire solar system. But how does this gigantic energy source work? Let's discover together. First of all, did you know that the Earth is located in a region of the sun known as the habitable zone, or the Goldilocks zone, which is neither too far nor too close to the sun, so that we can get the light and heat we need for life? But have you ever wondered how the sun generates energy and how it reaches the Earth? Let's take a closer look at how the sun produces energy. To give a simple answer, the sun is a gigantic fusion reactor. According to scientists, this process began when a huge cloud of gas and particles, a nebula, collapsed under the force of its own gravity. This created a huge ball of light at the center of the solar system and triggered hydrogen atoms to accumulate in the center and start creating solar energy. So how does this process work? Let's examine it in detail. The sun's energy is produced by the process of nuclear fusion in the core. In this process, hydrogen atoms turn into helium atoms, and a huge amount of energy is released. The temperature and pressure in the sun's core make this transformation possible. The temperature in the core reaches 15.7 million Kelvin, and the pressure reaches 250 billion atmospheres. Under these conditions, 4 hydrogen atoms turn into 1 helium atom, and a huge amount of energy is released during this process. This energy is radiated out in the form of light and heat and reaches our planet. This enormous release of energy takes place in only a small region of the sun. Some 99% of the sun's total energy is produced in 24% of the core. This energy spreads from the core to the outer layers, eventually reaching the surface and spreading out into space. But how does this energy get from the center of the sun to Earth? This process involves several important steps, and the layers of the sun play a critical role. Here are these layers. The core. It extends from the center of the sun to about 20 to 25% of its surface, where hydrogen atoms turn into helium nuclei. This process releases an enormous amount of energy. The nuclear fusion process in the core takes place when 4 hydrogen nuclei fuse into 1 helium nucleus. During this transformation, 2 positrons and 2 neutrinos are released, and these particles carry energy. The core is the densest and hottest part of the sun, and the energy produced there radiates outwards to other layers of the sun. Radiative zone. Located right next to the core, this layer allows energy to radiate outwards. In this region, photons emitted by hydrogen and helium ions are reabsorbed by other ions, and this process allows energy to be transported. In this region, the temperature drops from about 7 million Kelvin to about 2 million Kelvin. The radiative zone plays an important role in the sun's energy transport, and this energy travels towards the surface in the form of light and heat. Convective zone. This is the outer layer of the sun, where heat is transported to the surface by convection currents. In this region, due to lower temperatures and densities, energy is transported by convection currents. Rising thermal cells carry heat to the surface, and cooling cells move back inland. The convective zone plays a critical role in transporting the sun's energy to the surface. In this region, the temperature drops from 2 million Kelvin to about 5,700 Kelvin. This temperature drop causes convection currents to form, which carry heat to the surface. Photosphere. This layer, the visible surface of the sun, radiates energy into space. The temperature in the photosphere ranges between 4,500 and 6,000 Kelvin, and this layer transmits the sun's light to Earth. The photosphere also contains sunspots, which form in areas where magnetic fields are concentrated. Sunspots are colder than their surroundings and are an indicator of the sun's magnetic activity. The photosphere radiates the sun's energy into space, which reaches the Earth and sustains life. Energy emitted from the surface of the sun travels through space and reaches the Earth. This energy is filtered by the ozone layer in our atmosphere and provides our planet with the light and heat necessary for life. This process enables plants to photosynthesize, regulates the life cycles of animals, and is critical for the continuation of life. Energy from the sun also plays an important role in shaping winds, ocean currents, and climates. This energy maintains the Earth's energy balance and allows the planet's natural processes to continue. The sun is at the center of biological and chemical processes on Earth. It enables plants to photosynthesize, regulates the life cycles of animals, and is critical for the continuation of life. Without the sun, plants cannot produce energy, leading to the collapse of the entire ecosystem. The sun's energy also affects our climate and weather. The sun's activity interacts with the Earth's magnetic field and can create magnetic storms. These storms can affect power grids and cause disruptions in communication systems. The importance of the sun has been recognized by many cultures throughout history and is often regarded as a god. Gods such as Ra in ancient Egypt, Helios in Greek mythology, and Huitzilopochtli in the Aztecs have symbolized the power and importance of the sun. However, understanding how the sun works is only the achievement of the last few centuries. Ancient civilizations created calendars and regulated agricultural activities by observing the movements and cycles of the sun. The rising and setting of the sun has been the center of important rituals and celebrations in many cultures. The movements of the sun determine the change of seasons and agricultural cycles. Therefore, observing and understanding the sun has been an important part of human history. Thanks to research by physicists, astronomers, and biologists, we now better understand the processes by which the sun generates energy and how this energy is distributed throughout the solar system. Comparisons with other star systems and exoplanets also reveal the uniqueness of the sun. Learning more about the sun's energy also helps us understand other stars and planets in the universe. By studying the sun's properties and behavior, we can understand how other stars work and how they create conditions suitable for life. The sun's energy has also been a source of inspiration for future energy sources and technologies. Solar energy is used around the world as a clean and sustainable source of energy. We learned how the sun generates energy and how it reaches the Earth. Don't forget to subscribe to our channel and like our videos to learn more about the secrets of the sun and the depths of the universe. Also, if you have any questions about the sun, please share them with us in the comments. See you in our next video in the fascinating world of science and space. Bye.